Chapter 6: How Science Works. Most people have a great respect for scientists and what they say. But are scientists always right? Before we can evaluate what scientists say about how life began, we need to understand what science is and how it works. Perhaps the best way to find out is to become a scientist yourself. Follow the suggestions in this chapter and think like a scientist. Let's suppose you and a friend, Red, have an argument. Red says, "I'm a better runner than you. Redheaded people are good runners." Why, redheads are the best runners in the world. Any redhead can beat any blonde any day. Now, you can just sit there and argue. Sometimes people like to argue and don't want to find out who is right. But Red's statements can be tested. In scientific terms, he has stated hypotheses, and these can be falsified or shown to be wrong. And you can figure out ways to test his ideas to see if they are supported by evidence. If the evidence is against one of his ideas, that idea or hypothesis is probably false. Look at some of the statements Red made. What experiments can you think of that might provide evidence that Red is wrong? Cover the right side of the chart below and in the middle write ways you could test each of Red's hypotheses. How scientists test their ideas. When you thought up experiments to get evidence that Red is wrong, you began to think like a scientist. This is basically what the scientific method involves. Someone develops a hypothesis. They plan and conduct experiments to get information that will show whether or not the idea is correct. Some of Red's ideas or hypotheses can be falsified easily. "I can run faster than you" is easy to prove wrong. You just run a race. Some experiments you think up will be harder to conduct. In testing Red's idea that redheads are the best runners, it's impossible to line up every person in the world for a race. So you need to decide ahead of time what experiments you can conduct that will provide strong evidence for or against Red's idea. For instance, you might go to track meets and observe the races, or buy a track magazine and check hair color and photos of winners, or find a book on track champions and see if their hair color is mentioned there. Any redhead can beat any blonde any day also seems easy to falsify. Simply race the fastest blonde you know against a redhead you think is slow, or race 10 redheads against 10 blondes. If any blonde wins, that hypothesis of Red's has been falsified. So the scientific approach seems to give us a quick and easy way to test what people believe. It's not really that easy. Sometimes when we argue with people like Red, we get upset because they don't seem to play fair. Let's suppose you said to Red, "You think you can run faster than me? Prove it." You start off together and sure enough you beat Red to the corner. "There," you say, "redheads don't run so fast." "I beat you. That proves you're wrong." But Red, leaning against a tree to catch his breath, keeps on arguing. "I didn't mean I could run faster than you today. I've got a cold and can't run as fast as I usually do." Now this doesn't seem fair at all. Red said he could run faster. You raced and you won. Red was wrong. So how can he keep on arguing with you? In scientific terms, you conducted an experiment, observed the results, and those results falsified his hypothesis. The facts seem to show that his idea is wrong. Shouldn't Red just give up and admit that redheads aren't faster? But Red's claims that he can run faster and that any redhead can beat a person with another hair color are just hypotheses. Each hypothesis is rooted in a more basic idea. That basic idea is the underlying theory. What, then, is the theory that lies behind Red's claims? Red believes that hair color is related to running ability. What happens when hypotheses drawn from a basic theory are tested? And what can scientists' experiments prove? Let's go back to Red's refusal to give up his theory in spite of his defeat. Even though you beat Red in a race, your win did not prove that redheads aren't better runners. Even if most of the champion runners of the past were blonde or had dark hair, Red might still be right. Red-haired people still could be better runners. There are more people with blonde or dark hair than there are redheads. Out of 100 people, 3 might have red hair. There is a better chance of having a very fast runner from a group of 97 than from a group of 3. So possibly Red is right, and the average red-haired person is faster than the average blonde or brunette. None of the experiments that we've thought of will falsify that. To really test Red's theory, we need better experiments. For instance, we need to make sure that the only thing to affect the results of our experiments is hair color. Maybe Red had a big meal before you raced. Maybe he drank too much water. Maybe he had a sore heel. Maybe your legs are longer than Red's, and if your legs were the same length, he would have won. A scientist has to set up experiments very carefully. He or she will want to have the runners run on the same track, in the same kind of shoes, with the same training, and under the same variety of weather conditions. The scientist will want to adjust for weight and height. Also, the scientist may repeat the experiment many times. How many times should races be run under each condition to be sure of the results? 1, 10, 100? 100 races may seem like too many, but suppose you and Red raced 100 times, and Red won 7 of the first 10. You might win 75 of the next 90. So good scientists need to be extremely careful about the experiments they set up to gather evidence for or against a hypothesis. They know that no experiment can guard against everything that might affect its results. Developing better theories. Let's suppose you've run a number of races against Red and have even conducted other well-planned experiments. You take your results to Red and show him the evidence. There, you say, redheads don't run so fast. But Red keeps on arguing. Just because you held a bunch of races doesn't mean that redheads aren't faster most of the time. Besides, you ran short races. I meant that redheads are better in longer races. Now this really doesn't seem fair. You have solid evidence against each of Red's hypotheses. Shouldn't Red just abandon his theory? Well, if both you and Red want to go about this scientifically, Red should not give up. Actually, in science, this kind of thing happens all the time. When results of experiments don't turn out, scientists are often led to modify a theory instead of abandoning it. Most theories need to be modified. They need to be changed for better definition. Remember, you and Red started to argue about running fast, but neither of you said what running fast meant exactly. Did Red mean run fast for a short distance, a sprint? Or did he mean run fast for a middle distance, such as a mile? Or run fast over a very long distance, say 10 miles? Suddenly something that seemed very simple and very easy to test has become quite complicated. Actually, while learning about things scientifically might seem easy, the scientific approach is very involved, and most basic theories are very hard to test. All too often, theories scientists have accepted as true have been rejected later. Just because a person is a scientist or gathers information in a scientific way does not necessarily mean that his or her theories will be right. Good science and bad science. Science is an approach to learning things. The scientific approach tests theories using experiments and gathering all sorts of data or information that will suggest whether the theory should be accepted or rejected. Sometimes rejected theories have been accepted later. Very often, theories that everyone accepted have been rejected later on. The point is, a theory is just a belief until it's proven to be something else. It can be proven true and become a fact, or it can be proven false and become fiction. Nicholas Copernicus, a Renaissance astronomer, had a hypothesis that the Earth and other planets circle around the Sun. In his day, most people accepted the idea that Earth was the center of the solar system. After all, the Sun seems to circle the Earth every day. Scientists of that day made a prediction designed to falsify Copernicus's hypothesis. If the hypothesis is correct, they said, the planet Venus will come closer to Earth and then move away from it. If that happens, the light from Venus will brighten and then get more dim. When people looked at Venus, they couldn't see any difference in brightness. So they claimed Copernicus was wrong. He had a hypothesis and there was a scientific way to falsify it. But Copernicus was right. The planets do circle the Sun. What had happened? Venus does get brighter and dimmer, but this change cannot be seen by the human eye. Today we have instruments sensitive enough to measure the difference. Was the experiment proposed by those who doubted Copernicus bad science? Not really. But when they assumed that one could tell the difference in brightness with the naked eye, they made a mistake any scientist might make. In 1910, scientists believed in what is called the nebular hypothesis. This explanation said that our Sun and the other stars evolved from hot, swirling gases as they cooled in space. Astronomers looking through telescopes saw great spirals in the sky that looked like swirling gas. Most astronomers viewed this as evidence for the nebular hypothesis. After all, they could actually see swirling gases that would one day become stars. Then, in California, a new 100-inch telescope was pointed toward the stars. Now the astronomers realized that the spirals they saw in space were not gas, but were galaxies, made up of 1 billion stars. What scientists had thought, that swirling gas clouds rotate in space, was not a fact at all. Good science constantly searches for new information and is open to correction. When scientists have wrong information or not enough information, the theories they accept are likely to be wrong. Good science doesn't jump to conclusions, so it was bad science to reject Copernicus's theory on so little evidence. Bad science can mean poorly conducted experiments, but most often the difference between good science and bad science lies in the conclusions a scientist draws. A good scientist will be cautious, while a less capable scientist will jump to conclusions. The ruling theory trap. What do scientists do when they have accepted a theory and just don't want to give it up? What if our friend Red simply doesn't want to give up his theory about red-headed people being good runners? Then no matter how much evidence seems to falsify his hypothesis, he might still insist his theory is right. To keep from abandoning his theory, Red can keep changing his theory just slightly. Red might say it is very red-headed people who are fast. Your experiments weren't conducted with people whose hair was red enough. Or he might say it is young red-haired boys and red-headed teenage girls who run fast. Red might accept the results of races redheads win as valid evidence and argue that when they lost, there was something wrong with the experiment. If Red keeps on refusing to accept your evidence, or modifies his theory every time you get new evidence that he is wrong, you might decide that for some reason or other, Red just wants to think of redheads as good runners. You can probably think of at least one reason why this might be a favorite theory of Red's. Red has fallen into the ruling theory trap. Red is so attached to his theory that his judgment is affected. Red cannot think objectively about the data because his judgment is controlled or ruled by his theory. In science, a person should remain objective and not prefer one theory to another. But scientists are human and often want to believe a theory, despite the evidence, especially when most other scientists insist the theory is true. And scientists can be prejudiced against others' theories too. This may lead a scientist to consciously or unconsciously accept evidence that supports his theory and to ignore evidence that doesn't fit the theory. This is what the scientists who opposed Copernicus did. From just one piece of evidence against his theory, they jumped to the conclusion that it must be wrong. Those scientists, just like Red, were caught in the ruling theory trap. It's something like this for scientists who want to believe in the theory of evolution. Most evolutionists really want to believe that everything just happened by chance. Of course, scientists who believe that God created all things want to believe in creation. So both evolution and creationism are ruling theories. It is very hard for a creationist to convince a scientist who accepts the theory of evolution that his favorite theory is false, in spite of evidence on the creationist side. Charles Darwin wrote about the evolution of all living creatures, and most scientists accepted his theory. Early evolutionists predicted that they would find fossil evidence of gradual change from one kind of animal to another in bones or fossilized bodies found in Earth's rocks. That prediction has proved false, but people did not reject the theory of evolution. Research has shown that even slight mutations are almost always harmful. Thousands of experiments have produced no clear evidence of beneficial mutations or shown how such mutations could be responsible for the great variety of living things. But most scientists still have not rejected the theory of evolution. Even now they are trying to figure out some way evolution might have taken place. Evolutionists insist that living things just happened to start up from the dead rocks and minerals and waters of our planet. Yet today, as we'll see later, strong evidence shows that life surely did not begin that way. Yet evolutionists argue that it must have, and that someday they will learn how. When people hold a ruling theory, they are likely to reject evidence against that theory, no matter how strong the evidence is. Is scientific proof possible? Could you prove to someone who believes in the theory of evolution that he or she is wrong? Probably not. Why? There is never enough evidence. You can prove that water boils at sea level at 212 degrees Fahrenheit by repeated controlled experiments. The doubters can see for themselves, but no one can go back and observe creation or experiment with history. When it comes to issues like evolution and creation, we have to reason from circumstantial evidence. There is much we can learn about the universe and about Earth and about living creatures by gathering evidence. But we never have all the information we need. Some data is always missing. So people must reason from part of the evidence. Yet the evidence we have makes it clear that the theory of creation is far better than the theory of evolution. There are things we will never know for sure or understand completely through the methods of science. How and when exactly did God create the universe? What exactly happened on Earth in the past? These are questions we will never be able to answer for sure. However, we can look at evidence that has convinced scientists who are Christians that there is more scientific evidence for creation than against it. And we can look at much evidence against the theory of evolution. Yet in the end, we don't believe in creation just because it is more likely scientific. We believe in creation because we trust what God has revealed to us in the Bible. But it is important to realize one thing. When some claim that the theory of evolution is a scientific fact, they are wrong. Evolution is just a theory, and it is a ruling theory held in spite of solid scientific evidence against it.